Welcome back. 10 more real exam-style questions for the Databricks Data Engineer Professional certification. All new. No repeats from part 1. Same rules. Pause after each question, lock in your answer, and count your score. Let's go. Question 1. A platform team hand schedules, optimize, and vacuum jobs across dozens of Delta tables, costly to maintain and often mistimed. They convert everything to Unity Catalog managed tables and enable predictive optimization. What actually changes? A. Databricks now owns the storage lifecycle. Predictive optimization runs optimize and vacuum automatically, whenever usage patterns say they're worth it. B. Nothing operational. Predictive optimization still has to be triggered per table on a cron schedule. C. Managed tables never accumulate small files, so optimize and vacuum are disabled entirely. D. Photon does the compaction. The table conversion itself is unnecessary. E. Predictive optimization only targets external tables. They converted the wrong way. The answer is A. Managed tables hand Databricks the table's storage lifecycle, and predictive optimization watches how each table is actually used, then runs optimize and vacuum for you, when they're worth it. The hand-tuned maintenance jobs simply get deleted. And no, maintenance isn't abolished, it's automated. Small files still happen, Databricks just deals with them for you. Question 2. A streaming pipeline uses foreachBatch to write every microbatch into 2 Delta tables, a raw table and an audit table. When the job retries a failed batch, duplicates appear. Which change makes the writes idempotent? A. Drop the checkpoint and use append mode. Delta deduplicates identical rows automatically. B. Use copy into with force set to true, so the same files can be reloaded safely. C. Enable merge schema. Schema evolution prevents duplicate rows on retry. D. Set a transaction app ID plus a transaction version equal to the batch ID on every write. Delta skips writes it has already committed for that pair. The answer is D. This is Delta's idempotent writes contract. Give each write a stable transaction app ID and a monotonically increasing version. Just use the microbatch ID. On retry, Delta recognizes the pair it already committed and skips the duplicate. It matters precisely because one for each batch writes to 2 tables. A failure between the writes would otherwise leave them inconsistent. And checkpoints stay, by the way. Delta never deduplicates rows for you. Question 3. You configure a job-level failure notification. Overnight, a task fails, gets retried, and eventually succeeds. No notification ever arrives. What's the most accurate explanation? A. Job-level failure notifications require 3 distinct task failures in the same run. B. Notifications only fire for notebook tasks. Jar and Python tasks are unsupported. C. Job-level notifications are not sent when a failed task is retried. To hear about every failed attempt, configure task-level notifications. D. Failure notifications require a webhook destination. Plain email isn't supported. The answer is C. From the job's point of view, nothing failed. The retry saved it. Job-level failure notifications are suppressed, while failed tasks are being retried. If you want to hear about every failed attempt, flaky infrastructure, silent retries, burning compute, attach the notification at the task level instead. And email is fully supported. Webhooks are just an option. Question 4. One job must run the same parameterized notebook for 12 retail brands, a different source schema for each, all in parallel. And the brand list has to change without editing the job. Which construct? A. A foreach task that iterates the brand list and invokes the parameterized notebook as a child task per brand, with a configurable concurrency level. B. 12 separate jobs, 1 per brand, triggered in parallel by a parent job running CLI shell tasks. C. A single task with a Python for loop over the brands. It avoids per-task scheduling overhead. D. 12 static tasks in the job YAML, no dependencies, all referencing the shared notebook. E. A continuous mode Lakeflow pipeline that fans out 1 run per brand from a JSON config. The answer is A. For each is the dynamic fan-out construct in Databricks workflows. It iterates a list supplied at runtime, spawns a child task per item, and lets you cap the concurrency. The notebook reads the brand from a widget and dispatches the right logic. Change the brand list, the job definition never changes. 12 static tasks would run in parallel too, but adding brand 13 means editing YAML. And a Python for loop inside one task? That's sequential. Question 5. A Lakeflow declarative pipeline must enforce two rules. Customer ID is not null, and age between 0 and 120. Invalid rows must be excluded from the target table. But the pipeline keeps processing, and the drop counts must show up in the quality metrics. Which expectation? A. Expect it drops invalid rows by default and logs metrics. B. Expect or drop. Invalid rows are dropped before the write, and drop counts land in the pipeline's metrics. C. Expect or fail. It rolls back the update and records the metrics for debugging. D. A Python UDF inside the constraint. Expectations accept custom validation functions. The answer is B. Expectations come in three flavors: warn, drop, and fail. Expect or drop is the middle one. Invalid rows are excluded before the write. Valid rows keep flowing, and the dropped count is recorded in the quality metrics. Plain expect is the trap. It only warns, and the invalid rows still land in your curated table. And constraints must be SQL Boolean expressions. No Python UDFs allowed inside them. Question 6. Analysts need to query tables that live in an external PostgreSQL database, straight from Databricks SQL. Live data, no copies, and Unity catalog permissions enforced. Which setup is correct? A. A delta sharing recipient for the PostgreSQL server. The open protocol federates any JDBC source. B. An external location and storage credential over the database's files, registered as external tables. C. A JDBC mount point on DBFS, with views created over the mount. D. A nightly JDBC read into managed Delta tables. That's what federation does under the hood anyway. E. A Unity catalog connection holding the PostgreSQL credentials, then a foreign catalog mapping the database, queried as catalog.schema.table, and pushed down to Postgres at runtime. The answer is E. Lakehouse federation is exactly two Unity catalog objects: a connection, host, port, and credentials for the external system, and a foreign catalog, which maps the remote database into the three-level namespace. Analysts query it like any other catalog. Unity catalog enforces the grants, and the query fragments are pushed down to PostgreSQL at runtime. Live data, 0 copies. Delta sharing is the distractor here. It shares Delta data outward to other organizations. Question 7. A 5-task sequential job. A, then B, then C, then D, then E. Tasks A and B succeeded. C failed. D and E were skipped. You fix C's notebook and trigger a repair run. Which tasks execute? A, only C. D and E remain in their original skipped state. B, all 5. A repair run always starts clean from the first task for reproducibility. C, D, and E, failed and skipped tasks rerun. Successfully completed tasks never do. D, all 5. A repair run cannot preserve results from the original run. The answer is C. A repair run re-executes only the failed tasks and their skipped downstream dependents. Here, that's C, then D and E. Tasks A and B keep their successful results from the original run. That's the entire design. Fix the broken step, finish the run, and never pay twice for work that already succeeded. Question 8. Analysts must join datasets by user identity without ever seeing a raw email address. Which pseudonymization technique fits? A. Suppression. Remove the email column from every dataset. B. Generalization. Keep only the email's domain. C. Column masking. Show partial values, like A*** at example.com. D. Tokenization. Random tokens, with a secure reverse lookup mapping. E. Deterministic hashing. The same email always becomes the same SHA-256 value. It joins, and it never comes back. The answer is E. Deterministic hashing gives you both halves of the requirement. Same input, same hash, every single time. So two datasets hashed the same way join cleanly on the hash column. And SHA 256 is one way. The raw email can't be recovered from what the analysts see. Tokenization is the tempting one. Tokens join too. But that reverse lookup vault means raw emails can be recovered. Exactly the re-identification risk the requirement rules out. Question 9. An auditor wants in plain SQL every table in a catalog with its owner and comment, plus who granted which privilege on each one. Which built-in Unity catalog surface provides both? A. Loop show grants and paste into a spreadsheet. Grants are exposed as queryable relations. B. The catalog's information schema. The table's view for names, owners, and comments. Table privileges for grantor, grantee, and privilege. C. Describe history on each table. Ownership and grants live in the Delta transaction log. D. Schema on read over the system audit JSON files on DBFS. E. The legacy Hive Metastore's system.governance database. The answer is B. Every Unity catalog ships a standard information schema. The table's view carries names, owners, and comments. Table privileges carries grantor, grantee, and privilege type. The whole audit is a couple of ordinary SQL joins, filterable, schedulable, no UI scraping. And describe history? That's data commits for one table. Ownership and grants don't live in the Delta log. Question 10, last one. A star schema. The fact table, 500 gigabytes, growing 5 a day, joins dim product at 10 megabytes and dim customer at 200 megabytes. Analysts filter by order date and product category. Which layout decisions are best? A. Partition the fact table by product ID and customer ID. Partition pruning on the join keys. B. Partition by product ID, then Z order by order date and product category. Z order handles all filter columns equally. C. Partition by order date and add cluster by product category. Partitioning and liquid clustering combine on one table. D. Cluster by order date and product category on the fact table. The dimensions are small enough to broadcast join automatically. No layout work needed. The answer is D. 2 complementary moves. Cluster the fact table on the columns analysts actually filter by. That's where 500 gigabytes of data skipping pays off. And leave the dimensions alone. At 10 and 200 megabytes, they ride Spark's automatic broadcast join, so the shuffle disappears with zero layout work. And the trap in option C, a table cannot combine Hive partitioning with liquid clustering. Cluster by replaces partitioned by. And that's all 10. How many did you get right this time? Tell me in the comments. If you missed part 1, it's linked in the description. 10 more questions just like these. And for full-length practice exams, head to testlogichub.com.